Hi everyone, welcome to the second video in a short tutorial series looking at how to build a linked list of nodes. In the first tutorial we looked at how to insert a node at the end of a linked list, and I designed a function here which took two node references and used them to process the list. Now actually I don't really know if this is working yet because I haven't seen any output. So what I'm going to do is create some other nodes. Let's say upbeat, happy, sad, confused. And let's insert these nodes into the end of the list using our insert@end function. The beauty of modular programming. Design the function, call it when you need it. Look at how manageable the main program is. Now that we've inserted some nodes into the list, I'm going to design another function called displayList. And all we need for the displayList function, I'm not designing it here, I'm calling it. Oops. All we need when we call the displayList function, we just need to send it the root. Okay, so the root reference will allow us to go to visit the beginning of the list, and then the function can process the list. So let's just drop down here. Just going to collapse my original function, public static void insert@end. Let's make another function, public static void displayList. And all it does is processes a list because it knows the root. So that's the starting point. Now, we need to visit each node in the list to display the data in the list, right? Don't use the root pointer to do that. My advice is don't move root. The first thing I'm going to do is create another node reference called search and assign it to root. Now what we can do is, if the list is not, this time we want to process the nodes. So if root doesn't equal null, it means the list is not empty and we can start visiting nodes. So there's a nice bit of logic. If root isn't null, let's visit the nodes in the list. So again, in fact, I might only construct this. I might do that here. Doesn't matter. And as we did before, while search.next doesn't equal null, system.out.print search.data, and then update search, like we did before. Right? Search equals search.next. That will take us to the next node in the list. Okay? So there's my design for the displayList function. I'm going to call it here. Let's see if it works. It's never going to work, is it? Ooh, nothing. Didn't get anything. And the program is finished, so there's nothing happening. What's going on here? Oh, check it out, guys. Root has been assigned null. That's as much as the main function knows. And every time we call insert@end, we're calling root is null. The main program doesn't know that the insert@end function updated, where is it? Insert@end, it updated root. Oh, so really, when we call this function and it finishes processing everything, we need to return root's new reference. Because the main program needs to know what the current value of root is. Okay? So when we insert at end, we need to grab the returned value, and that's the value that we're going to use the next time we call insert at end. Take a moment to think about that, guys. Does that make sense? Okay, we don't want root to be null all the time. Okay, the first time we called insert at end, root was updated. It's not null anymore, and the main program needs to know that. So let's run this program again and see if it's working. Oh, we've got it. Upbeat, happy, and sad. Upbeat, happy, sad. We're not seeing the word confused, which is part of the list. Let's try and figure out why not. I'm just going to take my search pointer. While search.next doesn't equal null, display the data and update search. While search.next doesn't equal null, display the data, update search. While search.next doesn't equal null, display the data, update search. While search.next doesn't equal null, display the data and update search. While search.next doesn't equal null or equals null. So we're out of the while loop and we didn't display this. We didn't have a chance to display this final node's data. What about while search doesn't equal null? While search doesn't equal null. Well, search doesn't equal null here, and search equals search.next. Search doesn't equal null here, 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 search equals search.next. So search finally reaches null. So in this situation, we want to visit and process every node in the list. So we're going to send search all the way to null. Okay? So in my display function, while search doesn't equal null, we're going to print out the data on each node and we're going to update search. So let's run that and see if it works. Yay! It worked! All right. See if you can get that working in your own IDE.